One. So, test 2 has 4 pages. That may be 4 or 5 questions. It just depends on how I deal with the 4 requirements of a binomial. Now, for those of you that don't know what I'm talking about when I say the 4 requirements of a binomial, that would be definitions test 2, where I detail for you the definitions you're responsible for. Somewhere in chapter 5, it says the 4 conditions of a binomial. What's that? It's at the very end of the video. I tell you the 4 conditions of a binomial. All right? Hell, because you're nice guys, condition 1, got to have a fixed number of trials. Number 2, each trial must be independent. Number 3, the projector better not turn off. I'm sorry. I'm trying. Number 3, don't forget what I was saying. Probability must remain constant. And the 4th condition, there has to be only 2 outcomes. So each trial must fall into 2 outcomes. Generally, we regard that as success or failure. Okay, however that might mean. Okay, but there can only be 2 outcomes. Those are the 4 conditions of a binomial. You are expected to know those 4 conditions. Those 4 conditions will show up on the test, either as part of question 1 or as question 2 on its own, but it'll be at the bottom it's on the bottom of the first page. Okay? Not saying it might be, not saying it could be. It will be on there. Now, you may choose to not know it, and that's your business. Okay, but it will be on there. All right? When you flip that, you're going to go to page 2. Page 2 is general probability questions. All right? General probability questions. And I'll tell you which ones of these I consider to be general probability questions. Page 3 is going to be a chart that looks very similar to this. Now, I might give you the chart the way I did here on this screen, or I would write it out in words like in a class of 50 people, 18 are males who preferred A, 6 are males who preferred B, so forth and so on. Okay? So it could be in words or it could be a chart. It's usually a chart, but if I'm having computer issues, it's words. Because this almost ended up being words when I handed it to you, I ain't going to lie. All right, so here we go. Starting with number 1, what's the probability we pick somebody who's a male? Well, there are 24 males. There are 26 females. That makes 50 people altogether. So the probability it's male is 24 out of 50. Now, people will say, do I need to reduce that? Yes, please do. Due to time constraints, I may not in this particular demonstration. Okay? Can you write it as a decimal? Yes, 0.48 is fine. Okay? I'm not a super smart guy, but I can usually convert fractions to decimals. All right? Probability of a female, in this case, is 26 out of 50, which is 13 out of 25, or 52%. We call these mutually exclusive. That is also one of the terms you're responsible for. Didn't say it would be on there, but it is certainly a term you're responsible for. Probability they like brand A. Brand A would be 30 out of 50, which is obviously 3/5. Probability like B, 20 out of 50, which is 2/5. Okay. Now, find the probability of selecting the male or someone who said B. There are 24 males in the group. And if it's not a male or someone who said B, there are 14 additional people who, while they're not male, did say B. So that makes the total number of males or someone who said B 38 out of 50. So the probability of selecting a male or B, 38 out of 50. Again, that's 19 out of 25 for those of you that are keeping track at home. Okay. Probability of female and A. And at that point, it's not sufficient. It's got to be a female who chose A. It cannot be one of these 14 people. It has to be one of these 12 people. Now, I did not say that the person I selected was a female or that they chose A. I'm asking for, out of the group, how many of them are females and that female picked A? And that would be 12 out of 50. And see, that's a different question. That's a wholly different question than this one. Okay? This says the person that was selected is B. That is information that is critical, because at that point, in essence, what you are doing is you are limiting yourself to just this group of people. By saying the line, which is B, you're saying the person selected is B, there's 20 of them. Out of that 20, how many of them are male? You okay? 6. So the probability of male given B would be 6 out of 20. Okay. Any questions on that? What's that? It's got to be somebody who said B, right? How many people said B? 6 and 14 is the number of people who said B. So it's got to be one of those 20. So it's 20. And then out of that 20, 6 of them are male. Are we good? I'm going to pause here for station identification and also to give a quick shout out to Chick-fil-A. Eat more chicken. We're back. Question of the day is pickles or no pickles? I vote no pickles. All right. What if 3 different people are selected? What if 3 different? Now this is huge, because this goes down to the whole with and without replacement thing. And you remember how complicated that is, right? You see, if I say 6 people or if I say 3 people are selected, now the question is, are we choosing the same people or different? And if I just say 3 people, you don't know. At which point you would raise your hand, or you walk your happy butt up here and you go like this. Hey, it says 3 people. Does that mean with replacement or without? And I will tell you what it means. But if it says 3 different people, doesn't that really mean you can't pick the same person twice? Think about it. I'm going to give $100 to 3 different people. I can't pick my son all 3 times. Right? I got to pick somebody else other than him. Now, it doesn't mean I can't pick him the first time, But the second time, you cannot re-choose that same person. So how many females are in the group? 26 out of 50, right? There's 26 females. So the probability that I select 3 people who are all female is going to be 26 out of 50 times 25 out of 49 times 24 out of 48. Which I believe is 13 over 98. If I did that mental math in my head correctly. Okay. I'm not super smart. I stayed at a Holiday Inn Express. All right. What's the probability of A and what's the complement of A? Now, I think on the sheet that I gave you, it said the complement of A. I don't think it used a symbol. Does that make sense? Huh? I think it just says, I think I told you the probability of A was 0.73, and I asked you what's the complement of A. Oh, motherfucker. So the complement of P would be out of 0.26. That would be 0.74. It's the complement of P. I apologize. Whenever I copied it, this symbol, remember I was talking to you about the math program I use? It allows me to do various symbols, and those symbols don't convert to Word. So when it sees them, it just gives it crap. And so I deleted it and rewrote it and clearly didn't pay attention. Okay. Now, we're going to roll 7 dice simultaneously. What's the probability that all 7 are even? That would be 1/2 to the 7th power. Does that make sense? That goes down to the whole thing about it's the probability of a single event occurring raised to the number of times it has to happen. That's part of being independent. Okay, it's called the multiplication rule. What's the probability that all 7 of them are 3s? That would be 1 out of 6 to the 7th power. Are we good? What's the probability that they're all the same? This is where it gets a little bit tricky. What is it? 1 out of 6 to the 6th power. Why? It doesn't, you got 7 dice. 1, 2, 3, 4, 5, 6, 7. It doesn't matter what this one is. What number this what number that is doesn't matter. What is the probability that this number is the same as that one? 1 in 6. 1 in 6, and there are 6 of them. 1, 2, 3, 4, 5, 6. So it's 1 in 6 to the 6. Okay. 7 dice are rolled simultaneously. What's the probability that all 7 are different numbers? It's not possible. at least one of them has to be the same as another one because there's only 6 options. The probability that all 7 are different. It wasn't a trick question. Right now, there's people go like this. No, that was a trick question. No, for real. That was a trick question. You cheated. You know, it would be the same thing as saying, you know, you got 13 people. What's the probability that they were all born in different months? It can't happen. Each person can only be born in one of 12 months. If you got 13 people, well, then somebody's got to share a month. Okay? So that cannot happen. Does everybody understand why? Because once you see why it can't happen, then, you know, it's like you have 3 cards. What's the probability all 3 cards have different colors? Excluding the Joker. No, there's only 2 colors. So the first one can either be red or black. The second one either can be red or black. The third one's got to match one of those 2. Right? It's just that's the way it is. All right. If a random number generated a 4-digit code, what's the probability that will match the last 4 numbers of your cell phone number? And assume that you have one. Because if you don't have one, then your answer is 0. And I know that because I put it on a test and I marked it wrong for a girl. And she came back up afterwards and was like, I don't have a cell phone, so it ain't getting mine. And I was like, that's a good point. That's a solid point right there. No, I marked it right because, I mean, it wasn't going to get it because I didn't really believe that she didn't have one because I don't have any way of proving it. I mean, I went to Passport and I looked and they didn't have no phone number listed. And I was like, well, I don't know. Maybe she's lying. She's telling the truth. I don't know. What's the probability you get the right 4-digit numbers? Well, you got a 1 in 10 chance of getting the first one. You got a 1 in 10 chance of getting the first one. You got a 1 in 10 chance of getting the second one. You got a 1 in 10 chance of getting the third one. And you got a 1 in 10 chance of getting the fourth one. Now, understand this. It's 1 in 10 because the numbers that you can choose from are 0 to 9. That's 10 possibilities. Okay. So no matter what your phone number is, it ends in 4 numbers. And it's 1 in 10 for each one. Okay. That is 10, 100,000, 10,000, 1 in 10,000. No, same thing. I want to see this. I would love to see something that corresponds to that, like this. However, if you wrote 1 times 10 to the negative 4, I'd give you credit. It means the same thing. Okay. We good? Are we doing okay? I mean, I'm trying not to go too fast, but fast enough to be I can get through them. Okay. Let me pause here. This part of the class is brought to you by Burger King. You can have it your way. Welcome back. I know you feel like you didn't go anywhere, but I did. We're going to draw 2 cards from a deck. Now, how many cards are in a deck? 52. Out of those 52, how many of them are 9? 4 of them are 9s, right? How many of them are black? 26. Now, again, this is what I hear from students all the time. Well, what if I don't know that? Well, then you're screwed on that question. Okay? Kind of like how many prongs are on a fork. If I ask you and you don't know, you're screwed. You know what? I don't want to hear about those salad forks. I'm talking about. And she's talking about a spork. All right. The only people who use sporks are KFC. I think they're looking good. All right. What's the probability that they're both 9? If we do replacement, now what does that mean? When I say I'm going to do it, assume replacement, what does that mean? We're putting it back, right? We're taking it out, we're putting it back. So we could choose the same number twice. That's going to be 4 out of 52 times 4 out of 52. Does that make sense? Now, what's the probability they're both black? That would be 26 out of 52 times 26 out of 52. That's a 26, by the way. It just doesn't look like it. What about C? What's the probability that they're both red and a 5? 2 out of 52 times 2 out of 52. We just got to miss up the middle of the screen. I don't know what the hell happened. All right, but multiply those together. Do we agree? Now, if we do it without replacement, what does that mean? The first one would still be 4 and 52. It would be 4 and 52. 4 and 52 times 3 and 51. Yes? Probably they're both black. 26 out of 52. Yeah, you can leave, honey. It's okay. We're almost done. 25 out of 51. What's probably they're both red and a 5? 2 out of 52 times 1 out of 51. All right. We're going to stop the first part of the review here. Look for part 2 sometime in the future.